Greetings, guys. Here's lesson 1. This is page 230 of our book. God, let me make sure that's page 230, section 5.5. We're going to do 7 to 16 all here. Now, the instructions are kind of vague, so you'll see I wrote in on the side here. When they say 2 theta, they want sine 2 theta, cosine 2 theta. When they say theta, they want cosine theta, sine theta. So, see these problems? I'm going to do 3 examples for you. That should get you through this whole section here. So let's look at the first one. I'm scrolling down. So, my first example says 2 theta. Given cosine theta equals 3/5 and sine theta is less than 0. So I have to think to myself, where am I located? Because everything that we do draws on something we knew before, and this is the good old-fashioned axe rule, or all students take calculus concept. If cosine's positive and sine's negative, where I'm looking would be right here in quadrant 4. So the cosine of this theta they gave me is 3/5. And lucky for me, this is a 3, 4, 5 right triangle, but that means 4 is negative to be right there. And they want me to find 2 theta. So let's start with this one. I'm going to do, that's the answer they want me to come up with. What is cosine 2 theta? Then they want me to come up with the answer, what is sine 2 theta? So I got to fill in these 2 blanks. So, what did they tell me? Cosine theta is 3/5. I used that information to find a reference triangle, and then I labeled all the pieces because I'm going to use, for cosine 2 theta, I'm going to use this version of it. Cosine squared theta minus sine squared theta is equal to cosine 2 theta. And I also know that when they write cosine squared theta, what that really means is the same exact thing as this. Same thing goes with sine. Hey, didn't they already tell me what the cosine of theta is? It's 3/5. So I could just replace the parentheses with 3/5. And I could square it. Minus the sine of theta, but you know, where am I going to get the sine of theta? From my reference triangle, and I'm going to say the sine of that would be -4/5, because SOHCAHTOA. Everything we do in trig is based on something we already know. Now, this is just computational. I'm going to find out the numeric answer, and I'm going to use exact values, no decimal answers. It's either a fraction or a radical, or sometimes a good old 1, a -1, sometimes it's a 0, but I want to find my exact values by computing it. So here we go. 3/5 squared just means 3/5 times itself. I get 9/25. Minus, well, -4/5 squared means -4 times itself on the top. That's 16. 5 squared on the bottom. That's 25. 9 take away 16 is -7/25. So what did I do? I found this first answer. I told them the answer to this. They want me to find sine 2 theta. Well, sine 2 theta, well, let's think about that, because we already have some double angle formulas. That's what they're getting at. Sine 2 theta is the same as 2 times the sine of theta times the cosine of theta. Well, heck, I already know what the sine of theta is. I drew a beautiful triangle. It's -4/5. I know what the cosine of theta is because they gave it to me. It's 3/5. I know that 2 times that just means I could do 2/1 times all that goo. And I end up with, on the top, 2 times -4 times 3, which is -24. On the bottom, 1 times 5 times 5, that's just 25, and away I go. I have found the answer to this part of the puzzle. Whoop, there it is. Voila. Those are the answers that they wanted me to find. So I'm just computing based on the information they gave me, but how do I get answers with respect to 2 theta? The ones they want are those two. That's what they're asking for. When you see the answer key, you'll know what I mean. I use this version of the cosine double angle formula. I could have used different ones. I could have used different ways to get this because there's 3 different ways to write that. But there's only one way to write this, guys, so I used what I had. Now, there's going to be different tricks you can use depending on the problem, but I don't want you to think that it's super crazy hard math. It's not. This is pretty easy math to get our numbers generated. And let's just move on. I'm going to go to the next example, but I made up different examples. There's some in the book that you can refer to. It says in the section, see example 1 and example 2. That's what you need to do. Let's take a look at this one. They want me to find 2 theta, so that means when I am done, I'm going to have an answer that says cosine 2 theta equals something, and I'm going to have an answer that says sine 2 theta equals something. I got to figure out what that something is. But this time, they didn't give me any sine or cosine. They gave me a tangent. Well, they gave me a tangent that happens to be a positive 3, and they're telling me that cosine is negative. Well, I'm going to draw a reference triangle again. And if I have a positive tangent and a negative cosine, there is only one location for that, and I use the ax rule, or all students take calculus rule, whichever way you want to do it. That puts me in quadrant 3. I draw myself a nice reference triangle, and I say there's the theta they're talking about. Tangent of theta equals 3, so I do opposite over adjacent. Now wait a minute though, this is on the negative side of things, this is on the negative side of things, so I don't want to make a sign error because that is how I blow it if I forget to label things correctly. But I also have to use Pythagorean theorem. Negative 3 squared, well that's 9, plus negative 1 squared, that's 1. That equals 10, whoops, and I'm going to take the square root of that to get my hypotenuse. And remember, the hypotenuse on any of these reference triangles is always positive. So it's a positive rad 10. So I'm going to do the cosine 2 theta thing just a little bit differently this time, just for kicks. If I wanted to, I know that the cosine of 2 theta could also be written using this version of the formula. I could say it's the same as 2 cosine squared theta minus 1. I don't have to use this guy again. I don't have to if I don't want to, but I could. But I just want you to show you there's variations that'll maybe streamline things for you. Because I look at that and I say, okay, well the cosine, based on my reference triangle, is this dude. I'm going to square that dude. I'm going to multiply it by 2, and I'm going to take away 1 from it when I'm done. And if I do that, well, negative 1 squared is 1. Rad 10 squared is 10. I'm going to multiply that by 2 and take away 1. Well, heck, I can even reduce here if I wanted. I could say that's just 1/5. Take away 5/5. See what I mean? What's that going to equal? Negative 4/5. And that is the answer they wanted for cosine 2 theta. Negative 4/5. And once again, there's going to be an answer key at the bottom of the page, and you can check it. You can go, oh, okay, I did these right. Now, does that mean I couldn't have done this, where I could have said, well, I could plug in information for that, plug in information for that? No, it doesn't mean I couldn't do that. I just figured I'd show you there's a different way to get there. But when it comes to sine 2 theta, I have to use this guy because I only have one version of this dude to work with. And if I wanted to, I'd plug in, well, what is the sine of theta? It's opposite over hypotenuse. What's the cosine of theta? Well, same thing as it was, -1 over rad 10. You'll notice I haven't worried about getting my rads out of the bottom or rationalizing because sometimes it takes care of itself for you, like it will in this situation. On the top, I have a 2 over 1 here, so I go 2 times -3 times -1. Don't make a sign error, that's 6. On the bottom, 1 times rad 10 times rad 10, that is 10. And I can reduce those because they're a reducible fraction. Whoop, I just wrote 2, even though I didn't want to. That's 3/5. That's the answer they want for this. Pa-boom. There we go. So sine 2 theta is 3/5. All I'm doing is I am plugging stuff into the formulas, and I can use different formulas depending on what they're asking for, except for this guy. And I get my answers. I get my results. Now, I got one more example I want to do for you guys, but if you looked at the original problems, let me go back up. If you look at the original questions I'm asking you for, some of them start you off asking for double angle answers, some are single angle. So when it says theta, they want cosine theta, sine theta answers. So my very last example, let's look at one of those. So my third example coming down here is this guy. It says find theta, which is, what do they really want from me? They want me to find cosine of theta and sine of theta. And it says given, now they're giving me a double angle that's equal to -3/4. And look how they're writing this information. They want me to look between 90 degrees and 180 degrees. Now, just a heads up, they could say between pi over 2 and pi. Either way, what quadrant does that put me in when I'm looking for my answers? It puts me in quadrant 2. Now, whoop. And I'm going to draw a reference triangle here. This is the theta they're talking about. But they didn't give me cosine theta equals -3/4. They said cosine 2 theta equals 3/4. So here's what I'm going to do. I've got many different versions of this. Cosine 2 theta could equal, if I really wanted it to, I could use this one because I haven't used this one yet. I could say that if I want. It's valid. It's a true thing. But I still don't know the sine. I don't know. They didn't give me a cosine of sine. They gave me this guy. But here's where I substitute. I say, oh, well, they told me this. This is what they told me. I have -3/4 equals 1 minus 2 sine squared theta. That's what I have. This is in your future, these are called trigonometric equations. We finish off the whole school year by knowing how to solve all these different kinds of trig equations, but that's computational stuff, so let's just work it. It's not that bad. What the heck? If I wanted to, I could move the 1 over here. I could do that. That's just -3/4, take away 4/4. I could call that thing -7/4 if I wanted to. What's it equal? It equals -2 times sine squared theta. I could multiply both sides here by -1/2. I surely could if I wanted to. And I'd end up with not much room left, so I'm going to scroll down. And I would say, I got a sine squared theta situation over here on one side of my equation. What's on the other side of my equation? Well, it's -1 times -7, that's 7. 2 times 4 on the bottom, that's 8. And I say, okay, sine squared theta equals 7/8. All right, but I don't want sine squared theta. I want sine theta, so I'm going to cheerlead and do a root. And I get sine theta equals, well, let's clean this up. If I multiply top and bottom by rad 8, I'm going to get rad 56 over 8. But you know what? Rad 56 is just 4 times 14. I could reduce, end up with rad 14 over, oh, I should have wrote it. Wait, that'd be 2 rad 14 over 8. And I can reduce and call that thing plus or minus rad 14/4. I could. But wait, there's more. Which one of these answers is correct? Let's look at our reference triangle. The sine of theta, that would be opposite over hypotenuse. And I could do that and say, I'm in quadrant 2. This should be a positive answer. This should be a positive answer. Now, if I wanted to, I have two sides of this triangle labeled now. I could do Pythagorean theorem and say the square root of 14, or square root of 14 squared, plus this unknown piece here squared, equals 4 squared. I could get this done going back to my old tricks, root, and I'd say, wait a minute, should that be a positive rad 2 or a negative rad 2 when I label this triangle? And it should be a negative rad 2, because I'm in quadrant 2. And then could I do the cosine from that? Yes, I could. I could say the answer there is negative rad 2 over 4. I totally could do that. That is not wrong to find the cosine of that answer. Now, you will see in the book that they will do different ways to get to the same result. Me personally, whenever I can get it down to a reference triangle that I could label, I usually do that, because to me that's just the quickest, easiest way to do it. But, you know, cosine theta, I could have found that different ways. I am not saying you have to do it, the one way, but let me show you this. Cosine 2 theta, they told me cosine 2 theta is equal to negative, I have to scroll up again, negative 3/4. That's what they told me. If I wanted to, instead of finding cosine using this method here that I just did to label my triangle, I could have said, you know what? This guy right here is the same as 2 cosine squared theta minus 1. I could say that is equal to negative 3/4. I could then do a very similar thing that I just did, and I could get, what is negative 3/4 plus 1? That's 1/4, right? And then I could multiply both sides here by a half. And I would get a cosine, here, I'm just going to move over here. I could get cosine squared theta equals 1/8. I could root this, and then I'd say cosine theta equals plus or minus, well, the square root of 1 is 1. The square root of 8, square root of 8. I could get this out of the bottom. I could. And I'd have plus or minus. Well, square root of 8 in the top is 2 rad 2. In the bottom, it's rad 8 times rad 8. It is 8. And cancel them out. That would give me a positive or negative rad 2 over 4. And then I'd have to go, wait a minute, I'm in quadrant 2, so which one of those answers makes sense? It would be the negative version of that. Huh? See, there's more than one way to get there. And the thing that can be the most beautiful part of trigonometry can also confuse you, because you're like, well, which way is the best way? The way that makes sense to you the most is the best way. That is the way that is the best. But you can end up in the exact same location. So, when you guys look at these problems, here I'm scrolling up to the top one last time. When you guys look at these problems in the book on page 230, realize what do they mean by 2 theta or theta. That's what they mean. Follow my instructions, follow my examples, and then check your answers. All the way here at the bottom, I already pasted in your answers. So here's the answers for that section.